you are eliminating as urine is also mixed with that blood. So the renal artery is taking oxygenated blood, but it also has the urine. What we eliminate as urine is also mixed in that blood. Does that make sense? Okay. Now, as the blood goes to the kidneys, this is where that urine gets separated from the blood. Right? Urine is separated and the blood goes back through the renal vein to the vena cava, and the urine that is separated from that blood is the one that goes through the ureter. See, it's broken here. The ureter, it comes to the bladder where it's temporarily stored until it is eliminated. Give me that one, please. Here, you can see the ureter here. So as the blood is coming through the renal artery, it has oxygen, gives oxygen, and it also has the urine mixed in it, right? So what happens in the kidney is urine is separated from the blood goes back to the vein, the vena cava through renal vein, right? Renal vein is taking that blood back to the vena cava. That blood that is flowing in the renal vein, now tell me, does it have urea?
Yes.
No. The blood in the renal vein, does it have urea?
No.
Does it have carbon dioxide?
Yes.
That's what you have to remember, right? So this has picked up carbon dioxide, but it has gotten rid of the urea, and that's what we call urine. What you have in the urine is urea is the major waste, excess salts, excess water, right? And whatever else we don't want in the blood. Like you may have taken some antibiotics, so metabolic products of the antibiotics, all of that is separated from your blood. That's what flows through the ureter, comes to the bladder, where it gets temporarily stored until it's eliminated through the urethra. Does that make sense?
Mm-hmm.
Okay, so now let's look at this one. So if you look at the this is the longitudinal section of the kidney. You can see that's the cortex. Cortex is always the outer region. Medulla is the inner region, right? That's the medulla. All of that is the cortex. That's the renal capsule, the connective tissue layer on top.
Can this be the cortex too?
What? No. This is all cortex. You see these blood vessels? Above that, all of this is the cortex. And the rest of it is all medulla.
Okay, the bubble of this the part is still called the medulla.
All of this is the medulla. Cortex is only above these arcuate arteries and veins, above the blood vessels. See? You see in a different color, right? Cortex has different color than the medulla. You can easily tell. You can't mistake that. And see, that's the renal artery, right? Renal artery is bringing the blood. Now, arteries always divide, right? End up as capillaries. So that's the same thing you see here. Right. Artery, renal artery becomes segmental arteries. These are segmental arteries. They divide further into lobar arteries, right? These are the lobar arteries. They divide again into interlobar arteries. See these? Those are the interlobar arteries. And the interlobar arteries then become the arcuate arteries. See how they are arching out, right? That's the arcuate arteries. And then you can see from the arcuate arteries, you can see a lot of branches going up into the cortex region, right? Those are what we call cortical radiate arteries or interlobular arteries, right? They are also called cortical radiate arteries. They are radiating into the cortex region, right? And from that's the cortical radiate artery. Same thing you see here. See, that's the arcuate artery, that's the cortical radiate artery or interlobular artery. And from the interlobular arteries, you have several afferent arterioles coming out now. Now, arterioles, afferent, A comes first, right? So, afferent arterioles come out, branch off of the cortical radiate arteries. That's the cortical radiate arteries. These are the afferent arterioles. And that's what you see here. That's the afferent arteriole. Afferent arteriole then divides and becomes network of capillaries. That's what we call glomerulus. That's the glomerulus. Now, the blood from the renal artery is going into the segmental arteries, lobar arteries, interlobar arteries, arcuate arteries, and cortico-radiate arteries, afferent arterioles. Now it's in the glomerulus. Glomerulus is just nothing but capillaries, right? Just as you can see the same pattern here. Arteries dividing, and ending up as capillaries. That's the capillaries here, glomerulus. Now the blood is here. Now the blood gets strained, right? Filtration, right? We use the word kidneys filter the blood. And this is where the filtration takes place. If you want to filter something, what do you need? Strainer, right? Say you're making tea, right? So when you're making tea, so you have water and tea leaves and everything else, whatever else you want to add, you're boiling everything with the milk, you add milk or sugar, right? Let's say you added all of that and you're boiling it, right? Once you boil it, don't you have to strain it? Yeah. You have to pour it through a strainer. When you're pouring it through the strainer, don't you use a cup to collect the fluid, right, the tea? Yeah. So your liquid alone comes into the cup. What stays in the strainer?
The leaves.
Bigger particles. Tea leaves stay in the strainer. But when it comes into the cup, that cup has milk, sugar, water, tea, everything, isn't it? Just like that. You picture the blood going through this strainer, right? The strainer here is the glomerulus, this network of capillaries. This Bowman's capsule, that's like a cup. You're collecting the liquid that goes through the strainer, right? So this is the strainer, and what you're straining here is? Blood, right? What stays in the strainer? Blood cells are too big, right? Red blood cells, white blood cells, plasma proteins. Proteins are too big. They don't go through either, right? So you have blood cells and red blood cells, white blood cells, plasma proteins. They all stay in the strainer. What comes into the cup is water, everything that is soluble in water, which includes nutrients as well as the waste. Urea, right? Urea as well as the glucose and amino acids and ions, salts like sodium, potassium, chloride, all these ions, they do dissolve in the water, right? So everything that is soluble in water comes into the Bowman's capsule. Now, we don't want to get rid of the nutrients, right? Urine, in a normal healthy individual, urine shouldn't have any glucose or amino acids or anything, right? So you have, so that fluid now has all the good things as well as the waste. And that's what is flowing now. See, from the Bowman's capsule, it's flowing through this tubule. That's what is called nephron, right? See, this tubule is folded, isn't it? That's why it's called convoluted tubule, because it's folded. It's closer to the Bowman's capsule, so it's called proximal convoluted tubule, whereas this is distal convoluted tubule. So you have Bowman's capsule, proximal convoluted tubule, loop of Henle, distal convoluted tubule, and then the collecting duct, right? So as this fluid is flowing through this tubule, proximal convoluted tubule, loop of Henle, and distal convoluted tubule, we want the good things back into the blood now. That's what is called, the next step in the nephron is the reabsorption, right? See this is the afferent arteriole that's taking blood into the glomerulus. Now this is what is called efferent arteriole. Now this efferent arteriole comes and surrounds this tubule, right? That's what you see here. We call them peritubular capillaries. These are the peritubular capillaries. They are surrounding the tubule, and so that they can take back, reabsorb, right? Reabsorb all the good things into the bloodstream, right? So they pick up 100% of nutrients, right? And the process you'll learn in physiology. Initially, it will be facilitated diffusion, and then there'll be active transport, right? So there is the co-transport and all that you learn in physiology. So 100% of the nutrients gets absorbed, necessary amount of salts and ions and everything, and a lot of water gets absorbed. Actually, the loop of Henle is for water reabsorption. So by the time that fluid filtrate comes into the collecting duct,